Hi, my name is Saran student number 100621699, and this is my assignment 2. So here's my forward rendering, here's my deferred rendering. This is my color, my normal in position, my G buffer. This is my full screen light, and you can see the light volume. And if I stop the camera, I'll be able to change the position of it in GUI. And you can also change the range of the light, the color of it, and also the diffuse intensity. This is my single point light, and as you can see, the range works. And if I have multiple point lights, and I can just add some lights. Oh, it's better if I draw some light volumes. So as you can see, there's different random lights. After 10 lights, it starts spawning cubes. As you can see, a cube right here. And after 20 lights, it spawns in cones. So you can see a couple of cones here and there. Now, if I can go to show light pass, and it's better if it's single light. So you can see the lights that are affected, the color goes away on it. So yeah. Alright, and now to show you my code. So from top to bottom, I'll just go down what I did. So this is my random function. It just gets two values, and that's how I do the random positions for the lights, the multiple lights. It just gives a random position. These are my shaders, my frame buffer, loading in meshes. Here I initialize the scene, so this is where I load in my scene, and this is where I load in my first light. I have a light class, and it's just a vector of lights. I'll just show that real quick. All it is just placeholders for the position, range, color, and intensity. And the CBP has nothing in it, as you see. It's just a placeholder, just to hold all the variables. Meshes, low texture. Okay, update the scene. So here I have move camera. So this is how, say if this is true, it would move the camera left and right. You can toggle this on and off by pressing F. Here it just moves the torus and the light while I'm moving the camera, so it has little movement of the light and stuff. And this is just my function for moving the camera up to the game object. So here I have a temp number of lights and a number of lights. So if the number of lights increases, change the vector to resize it. And here I just have it generating the lights. And here you can see I'm using the random function for the position, the color, and the light range. So the first 10 are spheres, the second 11 to 20 are cubes, and the last 5 are cones. And here just update it, so makes it so the temp number of lights equals the number of lights. This only happens if there's a new number of lights. And yeah, and this is just setting the positions. Minimize this. This draws a scene. Instead of putting my light meshes in this game objects, I made another one called light meshes, and I just draw that. This just sets material. This is my GUI stuff. Pretty simple. Okay, here I have my original scene FBO. So this is what I do for forward rendering, and this is my G buffer. So what I do is I draw the scene, right? Then if I'm supposed to draw the light volumes, right, the toggle, I'm gonna do this polygon fill mode, draw the light meshes. This is why I had this function to draw the light meshes, and then go back to the fill mode. If not, just use fill mode. And that's it for that. Here, just forward rendering, really simple. Just put in the unlit texture, draw it on a full screen quad. Okay, here's my G buffer. So I bind it. So I'm using, I'll go into this more when I go to the shaders, but all I'm doing is just binding it. For the first one, as you can see, it binds to texture 0, texture 1, and texture 2. So color, position, normal. This is my full screen light. So I put in my shader and I set in these uniforms. So for position, color, light diffusing, and this light path just says if you want the light path to be on or off, so it's additive or not. And I just bind all the textures, so color, normal, and position, and I send it up. This is single point light. Same thing as what I'm doing for full screen, but I add a number of lights, and that's pretty much it. It's just a different shader, so it actually takes in radius into account. Same thing for multiple point lights. So I have this for loop for my number of lights and have this prefix, and it has this little light prefix, and I use this prefix and I send it up how many times it has to send up for how many number of lights there are. And that's it for that. Here is just my keyboard function, so this is just safe. If you press any of the arrow keys, WASD keys, you just stop the moving camera, so you can actually move the camera by yourself. Here is the toggles, so one light source, toggle the light volume, G buffer position, normal, color buffer, multiple light sources, cycle to the light meshes, and add a new light. I put it as plus and equal sign because you have to on my keyboard you have to press shift plus to get the plus sign, and I found out that like it was confusing, so I just put it as the equal sign too because it's on the same key for me. And the F key is the toggle for if you want to move the camera to or not. So if you want to stop the camera or keep the camera moving. And I think that's it for the CPU side. Yeah. Okay, now to the fun part, the shaders. So let me look at my G buffer. So all it is you have three layouts, right? Your color, normal, and position. So your color, I just send in the uniform color, so just the color of the texture, or if I had a texture on that object, you would just use that. Then the normal, I just shifted it, so instead of being from -1 to 1, I put it to 0 to 1, and I send it up, and I just send up the position. Next is the full screen light. So here are my bindings, right? And then have a structure for the light. So position, color, light intensity. Here I have an array of lights, and I have one light since it's just a full screen light, so it's only be one light, and have a light path, so if it should be true or false. Vertex data, out color. This is just my light specular. This is just the diffuse function with the specular. So here you can see I'm using regular diffuse right here, and all I'm doing is I'm using the light position instead of I'm using normal, the position. So this is what I'm sending from what I'm binding, the sampler. So here, let's look at main first. So here's my color. So I'm just taking all these bindings to my normal position, and I'm getting the sampler and just getting the vector of it. Here I shifted back from, so say when you were back here with my normal, I shifted from -1 to 1 range to 0 to 1, but here I'm shifting it back from 0 to 1 to -1 and 1. Here's my lighting calculation. So for every number of lights, if the light path is true, do the diffuse function and add it to this lighting calculation. The lighting is just my color. If not, just equal it to the color. That's all it's doing if the light path is on or off. Now back to the diffuse. So all I'm doing is sending the color normal position from here, and so this is what number light I'm on from here, and position n.l, diffuse texture, color is pretty much a copy and paste from default, right? Just pretty much a copy and paste, except for the specular part. Specular part was my code, and then I just replaced the variables for it, and yeah, and I just got that, and then I just ended up. Now for my point light. Okay, so here's where it gets interesting. So now I add a new thing for the structure light. I have a radius. Now number of lights, I have a maximum of 25. Since it's on the project, I have light path still, and I have a number of lights uniform. So this tells me how many number of lights we have right now in the scene that we want to calculate. The same thing, exact same thing from the last one, just specular my diffuse function. Yeah. So here I'm getting the length of so the distance, what I'm getting right here, from the position of the light to the position we need to calculate. Then if the distance is less than the light radius, so if it's inside of it, do the lighting calculation. Same thing here, it just, instead of plusing from just adding the diffuse function to the color, we're just making it equal to the diffuse function for the light paths. So if the distance is smaller than the radius, that means it's inside of the light. Then do the calculation. If not, don't do the calculation. And that's it for shaders. Am I missing anything? Alright, that's all. That's it. Thanks for watching.